Hey guys, and welcome back to another video of Spark Plug. So in this video tutorial I will be showing you how to make this robotic gripper in Fusion 360. So I'm thinking to make this video in two parts, but I'm not sure quite now. It will depend upon how long the first video will take. So as you guys can see, this is the it has got two flange here and some connecting rod and two gears, which is operated by a servo motor, and they all are mounted on this white frame. So basically this is all 3D printable. You guys can easily 3D print it as it is. So the motor part is, I'm not quite sure. I have those of you who are my previous viewers, my previous video was on this stepper motor, so I have used the exact same stepper motor here just for demonstration. By the way, I am taking responsibility till this gear. It's up to you which motor you are using to make this gripper in motion. So let's get started without wasting any time. We will start by making one foot here, and then we will make a mirror copy of this. And remember that there are two options, either to make it thick, but I have chosen not to make only one, and then make it double like this. So there are, if I just hide this, there are two here, two separate bodies, and there are two separate bodies here. So let's get started. We will start by making this flange here. So switch to your space, go to create a sketch, and on the top plane we will start by making some sketches. So for starting, as you guys can see, it's a slotted here. We will start by making a slot. So let's go to slot, center to center slot, and make us, oh, one more thing, every dimension that we will be using is this, no. So make sure the dimension is mm. So just go to create, go to slot, go to center point slot, and make a slot like this. Press D for dimension and give this dimension as 22. The dia, right click on it and choose diameter. The diameter is going to be 10 mm. Yeah. Now press C for circle and make a circle of dia 3 mm here, a hole. Now once done, make a line, and from somewhere here make a rectangle like this. Currently just don't follow, you don't have to follow any dimension, just make sure that we don't have tangent relation, vertical relationship here. So let's go for perpendicular relationship. Make sure that both of these lines are perpendicular to one another. Press D again, and from this point to this line make this angle as 157.65. now once done, right click and align, and this align dimension is going to be 34. Yeah. So the next dimension is from this point to this point, the vertical one. So the horizontal dimension is 1.95 like this. Now if I just make a tangent relationship, so you don't have to give any other dimension for now. So you can see that my sketch is fully constrained. Now what I'm going to do, let me show you what I'm going to make this cuts and this cut. So for that I have not assumed any dimension. Let's see what I'm going to do here. I am just going to make a cut here, and about some distance like here I am going to make another cut like here to here, and make these two lines parallel to each other. Yeah, so you guys can just alter size of the tooth here as you wish. You will understand. Just give me some time here. So press C again and make a 3 mm dia of circle here also, and finish the sketch. Now I am going to extrude it. Select this one and this one. Just leave the outer part and extrude it upwards up to a distance of 3 mm, and it would be obviously be our new component. press shift and N to enable the color. Okay, if you are thinking that this is not suitable, so anytime you can just go to create a sketch and just alter the shape of it like this, and you may finish the sketch. So a reason that I didn't made any dimension is to allow us more degree of freedom to change the dimension at any particular time. So this is the exact portion that we will be making the teeth here. So as you guys can see, these are not considered when the teeth are considered. Okay, so we have completed making our gripper. So now the last thing is to make this connecting rods. So for that, of course, just hide this for now. Click on sketch and press C for circle. Make two circles like this and make two circles like this. Press L, join these two circles, press D, and the outer is going to be 7 and the inner is going to be 3. Repeat the same for here, 7 and 3, and this is going to be 31. Yeah, so and press line, make a line like this from this, press D again, and from this point to this point make this 1.5, then mirror this line up to center point and finish the sketch. Now extrude this up to a distance of 3 mm, and this again will be our new component. So once done, you can just give the fillet, or let me just to make the video shorter, I'm not going to make any fillets. So you guys can see I have created some fillets here and here. So these are all assumed, you guys can take care of that. So we have our first part and the second part. Now for the third part, I'm going to make this base here. So for that, let's create a sketch. Let me just hide this and create a sketch on top plane. We will start by making a top plane sketch. Press L for line, and from origin make a vertical line up to a distance of 62. So let's make a vertical line of 62, and for now just make it in construction mode. So I have a construction mode line here. Now from this point, draw a figure, something like this. Now once done, press dimension, D for dimension, and start giving dimension to them, just like I am doing here. Okay, so from this point to this point, this is going to be 20.5, the length is going to be 30.3. This one, a line dimension is going to be 18.85, and this one, okay, I don't know why, let me just delete this. Yeah, so our sketch is finally fully constrained, we don't need any dimension. Now I'm going to make 3 holes around different places. So all of dia 3 mm. So first is going to be here, second would be somewhere here, and third one would be somewhere here. All 3 mm dia hole. Now from this point to this point, make it 4. From this point to this point, make it 2.75. Now as per this is concerned, from this point to this point, this dimension is going to be 10.3 mm. From this point to this point, this dimension is going to be 7 mm. You guys can pause the video at any time to capture the dimension better. So from center line, this is going to be 6, and from bottom, this dimension is going to be 4. Now once done, I'm just assembling it like this, so you guys can snap that out and make Once done, go to mirror command, select all these lines, select the mirror, unselect the center line and select the center line as the mirror one and finish the sketch. Now we have a mirrored view. Press C for circle and write on this line, make a circle of dia 17 mm. Press D again and from this point to this point, make this dimension as 13 mm. Now in order to make it fully constant, I'm going to make a vertical line from here to here and make this line coincident to this one. So we have a fully constant sketch and a circle here, the dia 17. Now you may finish the sketch. Click on extrude and extrude it again up to 3 mm. This is going to be our new component and press OK. Now as you guys can see in my, if I just hide this and this, you guys can see this is there's a cut here. The reason for this cut is just to minimize the load, minimize the weight of this particular part, because we will working on these holes, not the part that is solid. So what I have done here, you guys can create any part, but to save the time, I have just drawn some random ellipse like this in order to complete the sketch. So this is just to make some designs. You can play it with as you want. So this is how this will look like. Now for the next part, of course, we will be using these two spur gears. So for that, go to utility, go to add scene and scripts and add scene, and the bottom you will find the spur gear for C++ and Python. So go for the Python. This is a logo for Python. So this is the scripts for spur gear. So just double click on it. It will run a spur gear toolbar. So just note that the dimension, the standard would be the meter part, and the pressure angle would be 20 degree. The module I am going to use 1.125. The number of teeth is going to be 24. Let the backlash be 0. As per the root fillet radius, make it 0.1. To thickness is going to be 3 mm. And the whole diameter is going to be 3 mm also. So we have a 3 mm thickness gear. The hole at the center of the gear would be of 3 mm dia. Number of teeth, this is the module, this is the pressure angle. Those of you who are not aware of this, you can just Google it out and check that out what these particular terms mean. So once you are done, just press OK. And within a few seconds, you will have your gear make. So this is a 3 mm dia hole at the center and this one. Now we will start by assembling our design. So those who are aware of the design, the first part of making an assembly in Fusion 360 is to ground the mother component. So in this case, our mother component is going to be this face. So what I'm going to do is, you can just rename the component for better understanding in time, but I'm not doing that right now. So just completely ground it. The first part, just ground it. So I can't move it now. I can move this and this, but not this one because it's grounded, right? So I will start by assembling these two parts. As you guys can see, these are assembled on top of this face. So we have a gear here and a tooth here. So we will start by assembling the gear first. So go to solid, go to assemble, go to joint and select the bottom part of your gear and this hole, and just go to motion, select revolute, and your motion is completed. Now right click on it and click copy. On the mother face, click on paste new. Remember to click on paste new, not on the paste, because paste new will unlink the new gear from the previous one. So just like so, you guys can see it's rotating here. Yeah, so do the same for the second gear also. This time the hole would be this point, and this is also rotating. Now if I just go to top view, just place the gear so that it don't intersect with each other. You can just place it anywhere, but slowly and carefully place it exactly at the center of the orange gear. So this is how, I don't think any conclusion. Once satisfied, just capture the position, so that if I just make any changes, I just revert the position and it will just go back to their original position. Right, now the second is going to be this portion. So for that what I'm going to do is go to joint, select the bottom face and this face here. This again is a rotating motion. Okay, yeah. Now for the tooth, I am going to click on joint, select the top face and the bottom face, and this is also going to be our rotating motion. Now we have a rotating motion here, as you guys can see here. Okay, now the next thing is to make this these two, what you call it, I don't know, you can just call it anything. So first we will start by making from this one, so you can capture the position or revert back to its original position. Yeah, so yeah, here it is. So we are working on, we will start by making a slot center to center. Make a slot like this, press D, and this dimension is going to be 31 and the dia is going to be 8, so the radius is 4. That's it, and the hole is already here. We just need to make a 3 mm dia hole here, so make it 3 and press OK. And once done, just extrude it downwards and the motion would be join, and the distance would be -3 because we are extruding it downwards. It will automatically get joined to this one. You guys can see now it's joined here. Just revert back the position and do the same for the blue gear also. Just same step from this point to this point, and the dia would be 8. Press D again and make this as 31. Press C and make a circle of 3 mm here and finish the sketch. Extrude it, select this profile, go downwards -3, and the operation would be join and press OK. Now yeah, once done, go to join and make this hole join with the bottom hole, and the operation would be join. Okay, so if I just go to top view now, if I just move this will move like this only. Okay, so we will just limit the motion. As you guys can see in my design, it is not moving beyond a certain point. So for now, just leave it like that only. Just revert the position, so leave it like that only. Okay. Yeah, so the next thing is to make the mirror of these two things. So for that, what I'm going to do is I'm going to go to construct a mid plane, and I'm going to construct a mid plane on these 2 points, between those 2 points. Already you can just make this plane as mirror plane also. So I'm going to go to create, go to mirror, the type would be components, select this one and mirror it like this. Okay, now again we need to provide the same dimension, same joint that we have did earlier. So click on these two, okay, and repeat the same step again and again. We will be using tons and tons of revolute joint for this. And for the last portion, just bottom part of this and the top part of this, and press OK. Now this is how this will move, and this is how this will move. Now just revert back the position for the restricted point. Now what I'm going to do is just go to top point. As you guys can see, this is the angle. If I just double click on it, this is the angle that on which our the hole was making, right? So just place it at approximately 90 degree. Yeah, I think 68 degrees is fine, or let's make it 67 degrees. Yeah, 67 degrees. Just I'm trying to make this 90 degree, and remember to do the same for here also. So let's make it 0. Yeah, now it's 90 degree, and to check that, you can just anytime, yeah, this is how this will look like. Okay, now just capture the position, because we have fixed or the initial position of the tooth closure. Just forget about this part. We will deal with in the later part of the design. And remember not to have any collision. As you guys can see, there is absolutely no collision anywhere. So but they are still working independently. So what I'm going to do is I'm going to create a motion link. Go to assemble and go to motion link, and the first joint is going to be this joint, and the second joint is going to be this joint. Now what it tells us that how much the revolution 1 will rotate according to the revolution 2. So what I'm going to Fusion 360 tell is that if we rotate revolution 2 by 360 degrees, the rotation 1 should also be rotating at 360 degrees, but the direction is supposed to be get reversed, because both of the gear will be working on different directions, right? So just reverse it and press OK. Now if I just move it, you guys can see that it is actually moving. So the gear, both of the two gears has 24 gears, so the gear ratio is 1:1, so we don't have to deal with the angle. So 360 degree of blue will be equal to 360 degree angle of orange one, but still you guys can see that they are colliding. So just revert the position to bring it back to the original position. So what I'm going to do is, this blue is currently at 0 degrees. I am going to tell Fusion 360 that let's just open it. For example, let's say yeah, this seems fine, or 60 degree angle. I'm just assuming the maximum opening of the tool. So let's say 60 degrees is fine, right? So let's just skip again. Now I'm going to joints, select this joint. This is revolute 2. So right click on it and click on edit joint limits. So click on maximum and minimum. So minimum is 0 degree. The maximum is that we have calculated there is 60 degrees, and you can just animate it. So this is the maximum and minimum limit that this particular gear will go. So if I just press OK, now what I will, Fusion 360 will restrict the motion beyond 0 degrees and 60 degrees. So it will just restrict the motion between 0 and 60 degrees, so we don't have absolutely no collision. If you think that this is a particular collision here, so you guys can just increase the minimum from 0 to, I say, 2 degrees or 3 degrees. Okay, let's give you example again. So if I thinking that this is getting too close to each other, right click on it. I'm going to make it 2 degrees like this. Okay, something is not wrong. Something is definitely wrong here. I don't know what actually happened. Okay, I think there might be some glitch, but so this is how the things will work. You can just check that gear is not colliding with each other, so that's good. Now the basic is just completed. Now we just have to double everything out. You guys can see that we have doubled everything. So for that, let's say this point, So I'm going to click on it, copy, and click Control V for paste, and this, the thickness is 3 mm, so just make it downwards by 3 mm and press OK. So again, I'm not taking any radius, you can just give the radius on your own. So, and remember, I have clicked using the paste as paste option, because any changes that we will make to this part will automatically be directed to the second part also. Now again, go to rigid group, go to rigid, because this particular is still movable, right? So we need to make it rigid with the master position. So just make them rigid, so I cannot move it now. Now as for the bottom part, you guys can see we have used this connecting rods only. So this is the connecting rod, so press copy and Control V, drag it, Control V, drag it. We need 1 2, how much, let me just, so 2 for the top, 4 at the bottom, so we need 2 more. So just Control V again and Control V again. We have a 4 connecting rod with us here. Now just move backwards and start making the joints. So we'll start by from this point to this point. This is the revolute, and where was it? I forgot one thing. I need to double this two portions also. So for that, just click on this and click on copy, right click and click on paste, drag it upwards up to a distance of -3 and press OK. Now again, make a rigid between these two, right click, drag upwards, make a rigid between these two also. So you guys can move it like this, just revert back the position. Now click on joint command, select this one and this one, make it join like this. So this is how this will look like, and repeat the same step for this portion also. So select this one, press OK, drag it upwards, repeat joint, select the bottom face of this circle and the top face of this circle and press OK like this. Revert back the position. Now for the top portion we have used gears, but for the bottom part we will not be using gears. So we will just be making these two connecting rod to do our job. Right click, drag upwards, select the bottom face of this one and this one and press OK. Now for the last, drag upwards, right click, drag upwards and this one and press OK. Right click, drag upwards, select this and press OK. Now we have our tooth working with all the joints necessary. Now what I'm going to do is we will be creating some punches for the center portion, remember, right? So for that I'm going to create a sketch, and on top of any position I am going to create a line of length 14 and make a I-shaped structure like this and give the dimension accordingly. So this is going to be 1, this is going to be 1, this is going to be 2.5, make this vertical, this is again going to be 2.5, and distance between these two is going to be 1.5, and this dimension is of course 14. So we have our sketch fully constrained. Let me just try fixing one point. So we have a fully constrained sketch with us, 14 mm long and let me just check the dimension once again. Finish the sketch, go to revolve, select this portion, the axis would be this, and it would be new component. So this is going to be our punch. So click on joint and go to motion. This is going to be our rigid joint. Select this one and select this face. It will automatically be get assembled onto this point. Now again, as I told you, Control C and Control V. I need 1, 2, 3, 4, 5, 6, 7. So this is 2, this is 3. So let me just skip this part to make the video shorter. We'll get back to you once we are done. Yeah, so I have done with all the joints. Let me just hide the joints and sketches and constructions. Yeah, so this is how this will look like. Now again, I am telling you, you guys can just deal with the radius. That will definitely give you a more beautiful and realistic view. Now for this gear and this flange is considered, I have just used the same hinge that I have used here with a 12 mm dimension, and this hinge absolutely it's quite easy. It's just an L-shaped extrusion to mount it somewhere according to your need. So I will just at the last will tell you about this gear also. So again, go to utilities, go to add scene and go for the Python type, and this time the module will be 1.1. the number of teeth will be 24 divided by 2, that's 12. Gear thickness would be 6 this time. The hole diameter will be altered according to you, so let's make it for 3 right now. Okay, now once done, let me just check again all the dimension, root pair again and press OK. Yeah, so so this is our gear here. Now go to solid, go to a sketch, and on top of this sketch make a circle of dia 17. Finish the sketch just and extrude these two profiles up to a distance of 5 mm like this. Now once done, go to joint, select this face and this face and just flip it like this. Yeah, this is okay. Now the motion would be of revolute, and go to top view and position and just make it in the center and press OK. So you guys can see that can be moved like this. So just drag it till it's get into the center and capture the position. Now bring back the joints. Now what I'm going to do will be linking these two joints. Remember the gear ratio here is 24 divided by 12. So gear ratio is 1:2. That means every 360 rotation that this would take, the blue would take 180-degree rotation. So go to assemble, go to motion link, select this joint and this joint. So this is our revolute 2. So every 360 degree the revolute for every 360 the revolute 2 would make at half of it, so 180-degree, and just OK. As you guys can see, the direction is still, so we just reverse it and press OK. Now if I just drag it like this, you guys can see it's moving like that. So no need to check that it's making contact or not, but it will make contact in actual conditions, right? So but we have earlier made a limit to this joint, so it will not allow, Fusion will not allow it to move beyond a certain point. Okay, now you guys can increase or decrease if you want the thickness of this. So let's decrease it and make it equal to approximately, yeah, this will work. Yeah, so Now the last part is to, this is the place where your stepper motor will come, right? Exactly like this. Now as for the teeth, you can just remove unnecessary teeth anytime. For example, let me just revert the position. uh, as you guys can see, the only these certain number of teeth are in working. So these are the teeth that you can remove or you may not remove, it's all up to you. I have removed it into the in previous version. So I just make an sketch a circle and just extrude cut all the unnecessary teeth. Now in the ideal position, what I'm going to do is I'm going to extrude this. Let's revert the position, or let me just, yeah, make it to the closest they can go and capture it and extrude it up to a certain point. Now once done, let me just hide this component and repeat the same step for this one. Just extrude it like this. Okay, now just bring back the component. So we have extruded the bottom component, and now on top view, this is our origin, right? So this is the center line that we have here with us. Yeah, so I'm going to make a cut, a rectangular cut, to make them equal with each other. So let's make this rectangle symmetric with origin line. Yeah, yeah, once you are done, you can just extrude cut it. So for this part, I'm going to extrude cut. Okay, I think I have done something wrong. Let me just delete this sketch and delete all these two extrusion as well. So the best way is to calculate the distance between these two and just make a extrusion for that. So let's just calculate the distance from this point to this point is 0.6 approx. So we need to extrude it up to a distance of 0.3 only, and do the same for here also 0.3. Yeah, so this is done. So this can also be removed by you just by extruding it and making an extrude cut. And as per the teeth is concerned, I think you guys can manage that out. I have just made an, what do you call that, zigzag line, and you just extrude it into the surface and just split body. You can just use that to split that particular body here and give the radius, make this flange here, and just to show, I have just assembled a stepper motor from my previous video. I will just put a link on this stepper motor, how to make this stepper motor in Fusion 360, in the description below. So hope you guys will enjoy. So please reach me. I have my email ID in the description below. In case you are any query, I am always there to help you guys out. So hope you guys will enjoy the video. Don't forget to share and subscribe. Thank you and have a nice day.